Good afternoon, I am Ramya from the Department of Mathematics. Today my topic is graph theory. Now we are going to see the definition of graphs. A graph G is an ordered triple. V of G, E of G, psi of G consists of non-empty set of vertices called V of G, a non-empty set of edges called E of G, and an incident function psi of G which associated with edges of G and unordered pairs of vertices of G. A graph is nothing but the points and lines are joining together, we get the graph. Consider the example. This graph having a number of 4 vertices and 4 edges. Here V of G is a set of vertices in this graph, that is V1, V2, V3, V4. E of G is set of edges in the graph, that is E1, E2, E3, E4. Psi of G is incident with associate all the edges of G, that is E1 is incident with V1, V2. That is the incident function of E1 is V1, V2. Next one, psi of G is E2. That E2 is incident with V2, V3. That is the incident function of E2. That is V2, V3. Next, incident function of E3 is V3, V4. Incident function of E4 is V1, V2. The number of vertices in the graph is denoted by capital V or modulus V or gamma. The number of vertices in the graph is denoted by capital E or modulus E or epsilon. So this graph having 4 vertices, so capital V equal to 4. This graph having 4 edges, so capital E equal to 4. This is the graph. Next we will see the finite and infinite graph. A graph is said to be finite or infinite according to the number of vertices is finite or infinite. For example, this graph is a finite graph. This graph having finite number of vertices, so this graph is a finite graph. This graph is an infinite graph. This graph having infinite number of vertices, so this graph is called an infinite graph. Next one is P comma Q graph. A graph with P vertices and Q edges is called a P comma Q graph. P is nothing but the number of vertices in the graph. Q is a number of edges in the graph. So a graph having P vertices and Q edges, that graph is called a P comma Q graph. For example, this graph having 3 vertices and 3 edges. So this graph is called a 3 comma 3 graph. Next one is terminal vertices and end vertices. Let E equal to UV be an edge of the graph G. The vertices U comma V are called end vertices or terminal vertices of the edge E. For example, this graph has 2 edges. This edge is incident with UV. So these 2 vertices are called end vertices or terminal vertices. In this graph E4, if you consider this E4, this edge is having 2 end vertices, that is V4, V3, because this edge is incident with V4, V3. So this V4, V3 are the end vertices of E4. V1, V2 are the end vertices of E1. V1, V4 are the end vertices of E5. V2, V3 are the end vertices of E3. So this is the end vertices or terminal vertices. Next definition is cell loop or loop. If the end vertices of an edge coincide, then the edge is called a loop. See this graph having a loop. Loop means the end vertices are coincide. In this edge, the end vertices are distinct. That is UV. This edge having only one end vertex, that is U, starting with U and end with U. So this end vertices are coincide, that is this edge having one end vertex. So this edge is called a loop. This edge is called a non-loop or link. Next definition is parallel edges. Parallel edges is 2 or more edges having the same end vertices are called a parallel edges. Consider this graph. This graph having 2 parallel edges, that is E1, E2. V1, V2 are the 2 end vertices of E1 and E2. So these 2 edges are called a parallel edges because these 2 edges having the same end vertices. So these edges are called parallel edges. Next we will see the definition of general graph or multiple graph. A graph having loops and parallel edges are called a multiple multiple graph or general graph. Let us consider, let us see the example. This graph is a general graph because this graph having loops and parallel edges. So this graph is called a general graph or multiple graph. Next definition is pseudograph. A graph having multiple edge or loops. So but not both. That graph is called a pseudograph. Next one is simple graph. A simple graph without loops and parallel edges is called a simple graph. A graph without loops and parallel edges. That graph is called a simple graph. Next, adjacent vertices. The end vertices of an edge are said to be adjacent vertices. In the consider this graph, this V1, V2 are the end vertices of E1. So this V1, V2 are the adjacent vertices. Here V2, V3 are the end vertices of E1. So this V2, V3 are the adjacent vertices. Here V3, V4 are the end vertices of E3. So V3, V4 are the end adjacent vertices. Next definition is adjacent edges. Adjacent edges means two or more edges having the same. If two distinct edges are incident with common vertex, then they are called the adjacent edges. Here these two distinct edges, that is E1, E2, are incident with one common vertex. These two edges are called adjacent edges. Here E2, E4, E3 are adjacent with one common vertex, that is V3. So E2, E4, E3 are the adjacent edges. Here E3, E4, E5 are incident with one common vertex, that is V4. So this E3, E4, E5 are the adjacent edges. Next definition is pendant vertex. A vertex of a graph is said to be pendant vertex if only one edge incident on it. That vertex is called a pendant vertex. We'll see the example here. V4 having only one edge incident on it. So this V4 is a pendant vertex. A pendant vertex means only one edge is incident on it. That vertex is called a pendant vertex. So here V4 having the only one edge incident on it. So V4 is a pendant vertex. Next, isolated vertex. Isolated vertex. A vertex of a graph is said to be isolated if no edge incident on it. That vertex is called an isolated vertex. See this example here. V6 is an isolated vertex because there is no any edge incident on it. So this V6 is an isolated vertex. V5 is a pendant vertex because only one edge is incident on it. So here V6 is a isolated vertex. V5 is a pendant vertex. Next we will see the complete graph. A graph is said to be complete graph if every vertex is adjacent to every other vertex. It's called a complete graph. In a complete graph, if you take any vertex in that graph, that vertex is adjacent to all other vertices. That graph is called a complete graph. These are the examples of complete graph. This is K1. K1 is a trivial graph. Trivial graph means the graph having only one vertex. That graph is called a trivial graph. This is K2 complete graph. This graph having two vertices. The two vertices are adjacent each other. That is K2 is a complete graph. Here K3. K3 also this graph having three vertices. So if you take any vertices in this graph, that is adjacent to any other all other vertices. That is here take here this vertices. This vertex is adjacent to here. This vertex is adjacent to this one also. So this is the complete graph of K3. This is also complete graph of K4 because this graph having four vertices. So this graph is a K4 graph. Next definition is degree of vertex. The number of edges incident on the vertex V of a graph G is called the degree of the vertex V in G, and it is denoted by degree of G, D of G or degree of G. The degree of the vertex is nothing but the number of edges incident on it. That is the degree of the vertex. Here we consider this graph here. Degree of V1 is 2 because these two edges are incident on it. Next degree of V2 is also 2 because here also two edges are incident on it. Here V3, degree of V3 is 3. 3 edges are incident on it. So degree of V3 equal to 3. The next definition is regular graph. A graph G is said to be regular if all the vertices have same degree. Example, you consider this graph. This graph having 3 vertices. The 3 vertices all of degree is 2. This vertex of degree is 2. This vertex of degree is 2. This vertex of degree is 2. So all the vertices in the graph of degree is 2. So this graph is called a regular graph. This graph is also called a regular graph. This is also regular graph because degree of all the vertices in this graph is 1. In this graph is 3. So this is 3 regular, this is 2 regular, this is 1 regular graph. Thank you.